Hi guys, I'm Roselyn Maraasin, and for today's video, we will talk about the topic Building in Electrical Systems. Overview of this topic, electrical systems in buildings. Basics of electricity to single or three-phase supply, protective devices and electrical installations, earthing for safety, types of earthing, types of wires, wiring systems, and their choice, planning electrical wiring for building, main and distribution boards, transformers and switchgears, layout of substations. Since the day end of the 19th century, virtually all buildings are provided with electric lightings. Installation for use at night with the advent of fluorescent lamp that is compatible with daylight, cheap to run and not emitting heat gain in buildings. It made possible to install electric lighting supplementing day light and in extreme cases provided the only source of light in the windowless environment. Several factors can exercise a critical influence on the success of lighting installations apart from proper level of illumination on the workplace. Thomas Edison, the direct current incandescent light bulb, while Nikola Tesla, alternating current fluorescent light bulb. The first use of electric supply were established in 1882 by Thomas Edison. Thereafter, there have been constant effort throughout the world to set up power stations for more than one purposes. The power generation in India in 1947 to 48 was only 4.1 billion, and today we generate more than 600 billion kilowatts. Electricity. The Havre power equation triangle. PVI. P is the power measured in watts, while V potential difference measured in volts. I is current measured in amperes. Voltage times current is equals to power. Power over voltage is equals to current. Power over current is equals to voltage. Electric generator. Electricity is generated from the stored energy of water that makes turbine run and generate electricity. The other method includes fuels, coals, diesel, or gas to fire boilers and pass stream and generate electricity through generators. Transformers step up several thousands or even hundreds of thousands of volts before it is supplied to the transmission lines or cable. By transmitting electricity at high voltage, less power is lost in the cables. At the receiving end, voltage is stepped down by transforms in local substations to consumers at 240 volts. As you can see, this is the example of electric generator. It has a turbine, generator, transformer, and then the electricity. Entry in the buildings. In urban areas, electrical cables are usually underground and are brought up to entry point at ground level or into basement service cable. Cannot be bent to small radii, and this should be borne in mind when considering point of entry. In small buildings, the cable run is kept as short as possible, terminating in a distribution board at the first convenient position. In these buildings, the distribution board will be fitted with a seal box to prevent moisture from entering the insulation of the service cable. A main fuse for the premises in a box sealed by the supply authority, and the consumer unit or other switch and fuse gear belonging to the building. The position chosen for the distribution board should be readily accessible both for meter reading and for replacing fuses. In some cases, special glasses are provided so that meter can be read without entering the premises. For domestic supply, domestic electricity supply is usually affected through distribution system and describe a single and three phases. Normally, small buildings are supplied with electricity by two wires, one phase wire and the other is neutral. This is known as single phase supply and gives a voltage for the premises of 240 volts. The loading of the supply wiring is balanced between the phases by using the phases in rotation so that each one services every third building. In three phases for wire bring 420 over 240 volts, 50 cycle per second. The voltage and Between any two of the phases wire is 415 volts, and between any phase wire and the neutral is 240 volts. The balancing of load is then achieved by serving different areas of the building with different phases. Electric motors are usually designed for three phases. This is the example of single and three phases distribution. Earthing system. In electricity supply systems, an earthing system or grounding system is a circuitry which connects parts of the electric circuit with the ground, thus defining the electric potential of the conductors relative to the Earth's conductive surface. Applications of earthing: protect human against lightning and earth fault condition. Second, protect the premises against lightning and earth fault condition. Third, provide low resistance, safe path for lightning and fault current. All metallic enclosure and extraneous conductive parts are at equipotential. And the last one is LV system, earth. As you can see, this is the example of applications of earthing. Basic wiring system. Types of wiring. There is a wide choice of wiring. However, one must keep in mind the safety of man and material. The various types of wiring used are discussed below. Complete wiring. In the system of wiring, VAR or PVC insulated wires are held to the walls and ceiling by means of porcelain plates, which are fixed at a distance of 0.5 meter horizontally and 0.75 meter vertically. Above the walls, the plates are made of two halves. One is known as base and the other is known as top. The wirings are drawn into grooves and finally tightened. This wiring is cheapest and requires little skill and can be quickly installed. Conduit wiring. In this type of wiring system, VAR or PVC are carried through steel or PVC tubes as conduit. In case of surface conduit wiring, the conduit fitted on the surface of the walls by means of saddles, and in case of concealed conduit wiring, the conduit to facilitate the drawing of wires. And this image is an example of basic wiring systems. Ducts for electrical distribution. In addition to the wiring systems, there are a number of ducts available, specially designed to contain electric cables in particular building stations, and it is consist of an inflatable rubber tube which is placed in concrete formwork. And for pouring concrete, after concrete has set, the duct tube is deflated with flow from concrete, leaving a duct for electric wiring or other purpose. If overhead distribution is systems that are clearly more economical and more flexible than other. This is the example of ducts for electrical distribution. Insulations. On the basis of insulations, the cables may be classified as follows. Number one is paper insulated cables. In these cables, paper is wound on the conductor in successive layer. The archive required dielectric strength. Such cables are manufactured in various sizes from 5mm to 500mm cross section. Conductors and voltage rating support to 33 kV. Number 2 is PVC cables, 3 oil. This is example of insulations. Of course, we don't have to forget the external protection against mechanical damage or electrochemical attack. Fire or any other deleterious influences external to be the cables can be minimized if certain points are taken in account.
Image below is
Cable should be at least 0.5 meter away from the communication cables. Whenever a cable crosses a road or railway line, it should be laid in pipes or conduits. External protection sample. Appliances. There are many ways in which electricity can be used to save labor in the home. A vast number of appliances are designed to run on the ordinary domestic supply. The three basic applications of electricity are the production of heat, light, and in many devices they are used in combination with electronic appliances such as radio and television sets. substitute first class and telephone fuses. All the electrical appliances requiring a current of more than 5 should be fitted with an earth or ground wire to safeguard the user against shock from leakages of current. Their supply cables that carry key. There are 3-pin plugs and then best type of socket no current can flow until the earth's pin can be made its contact. So we have here the example of electrical appliances. Electric installations, design and planning. Of course, the design and planning is an electrical installation governed by the type of user, building, and consumer thereof. Therefore, it is essential to consult a competent electrical engineer or licensed electrical contractor at the planning stage for providing and planning electrical installations, which should be safe and either client in its use and adequate for its extended or intended purpose for designing laying out electrical installation for specific requirement of power use. It is also the essential at planning stage at the architect and consultation with structural engineer, electrical engineer, and owner or developer to decide. This is the example of electric installations. Alternate source of electric supply. A standby electric generator should be installed to supply power to staircase and corridor lighting circuits. Fire lifts, the standby fire pumps, smoke extraction, and damper systems in case of failure of normal electric supply. Generators should be capable of taking starting current. Of course, machines and circuit stated above simultaneously leave the standby pumps driven by diesel engine. The generator supply need not to be connected to the standby pump. Transformers in building electric systems. A transformer can accept energy at one voltage and deliver it at another voltage. This permits electrical energy to be generated at relatively low voltages and transmitted at high voltages and low. For the last part of this topic, a substation layout. Primary power line side. So we have one is primary power lines, 2 ground wire, overhead lines, 4 transformer for measurement of electric voltage, 5 disconnect switch, circuit breaker, current transformer, lighting arrestor, and second part is secondary power line side. Number 7 is current transformer, lightning arrestor, main transformer, control building, security. As Nikola Tesla said, the desire that guides me in all I do is the desire to harness the forces of nature to the service. That's all for today's video. I hope you enjoy. Thanks! For the last part, substation layout. Primary power line side. Primary power lines, ground wire, overhead lines, transformer for measurement of electric voltage, disconnect switch, circuit breaker, current transformer, lightning arrestor. And B is the secondary power line side. Current transformer, lightning arrestor, main transformer, control building, security fence, secondary power